Hello everyone, this is John from Vulgar Kitten Studios, and today we're going to go ahead and get our camera working. Now, because this is an incredibly large amount of code, all I'm going to do is I'm actually going to copy in pieces of the code a little bit at a time and explain what's going on. So if you need to pause the video in order to keep up with typing it all out, then definitely do so, and it's probably better that you do that anyway. But definitely this is a lot of code, so this may take some time. So let's just go ahead and get started then. First of all, we're going to be working with the camera or the player target, and the player target and the camera script actually have to work together. So we'll open up our scripts folder, and we're going to go ahead and open up our player camera script, and we're going to open up our player target script. And we'll work in our player target script first, so I'm just going to go ahead and open up my regions here. And we'll come into the player target, excuse me, and we'll go ahead and start setting up our public variables. So we're going to need two texture 2Ds, and just call those target and target over. Now target over we're not actually going to be using yet because we don't have any enemies in the game yet, but I do want to go ahead and include this functionality just so we don't have to worry about that in the future. We can just configure it a lot faster. Alright, so we have references to those, and we're also going to need a couple of booleans. One to check to see if we're over an enemy, and one to check to see if we're aiming. And we're actually going to need two layer masks as well, one for our enemy layer and one for our other layer, named appropriately. And we're going to get a reference to how far our enemy is away from us, and just go ahead and paste that in there. And I'm just going to say that that is 50 by default. And we'll need a reference to our camera, so we'll make a public camera and just call it player cam. And we'll need a reference to our player's transform, so, or not our player's transform, but our player's target. So we'll go ahead and put that in right there. And we'll need a reference to our player controller, so we'll make a reference to that mono behavior here. And we'll need a reference to the player camera mono behavior as well. Now for our private fields, we're going to just go ahead and make a private reference to see if we're over the enemy. So we have a public and a private, so that's how that works. And we also have the same thing going on for our aim too, so we have an over enemy and an aim private boolean as well as publics. And we'll need a GUI texture, which we're just going to call GUI. Now I know that we have a wonderful new UI system in Unity, but I'm just extremely used to using the old UI system, so that's what I'm going to be doing. If you want to convert this over to using the new UI, then definitely be my guest, but for right now I'm just going to be using the old legacy GUI system. And so we'll come down into our start method, and we'll just need to initialize a couple of things. We'll set our player target dot parent equal to null, and the reason why we're doing this, let's just come back into Unity, is because our player target apparatus, the object that has our player target script attached to it, also has a child object called player target, and we want to clear that so we can move it around. We don't want it to have a parent, so we're going to go ahead and clear its parent transform via script whenever it starts. And so we'll go ahead and set our GUI to be GUI texture, so our GUI texture component right here, which has our target deal here, and we might as well just go ahead and assign these textures. So set the target right here and the target over to our target over, and matter of fact, we can go ahead and set up the rest of these as well. We're not going to worry about the enemy or the other layer or even the enemy distance for right now, but we're going to go ahead and take our player camera and put that on the camera, so it's getting the camera component of the player camera. And we also need to get the script component, so our player camera script from right here. And so our player target is going to be our player target, our child object of our player target apparatus, and our player controller, we need a reference to our player controller script. Okay, so we'll come back into our code, and we'll need to set the GUI pixel inset just like a rect, but we're using the GUI pixel inset, which is in the transform components of a GUI element. So here we go. I'm going to position that right there so you can see all of it. And we just want to set we want to put it in the middle. So we're going to say minus target dot width for the x multiplied by 0.5, effectively cutting it in half, and negative target dot height multiplied by 0.5, target dot width for the width, and target dot height for the height. Okay, and now that we have that, we also want to get the target texture. So we'll say GUI.texture is equal to target, and we're going to set the color of that as well. So I'm going to go ahead and just put that right there, and we just have these RGBA values here, and we'll adjust the alpha value accordingly based on different states, that is. So we'll come down to our update method, and we're going to do a check. We're going to say if not our playercam.gameObject.activeSelf, so if it's not active, then we want to set our GUI color to be equal to have 0 transparency, basically. And then we'll just return out of this check, and then we'll say that our public aim boolean is equal to our input again. And I suppose that we could have actually just said our player controller aim, but just to make sure that there's no latency in between those checks, we're going to get the input access directly. And matter of fact, we need to put in our using globals up here, and so that way we can actually appropriately check for our player input. And now we actually want to draw a ray from the center of the camera to a point in world space. So what we're going to do is we're going to create a ray and call it ray, and then we're going to use the screen point to ray method on the player camera, or on the player cam, the camera component, and we're going to say that's equal to a new vector 3, and we want to use screen.width divided or cut in half, and screen.height cut in half, and 0 for the z. So essentially just like a rect would be. So I'm sorry, I can explain this better. What this is doing is saying from the very center of our viewport we want to fire a ray out straight. Okay, so that's what we're actually doing. Sorry for the confusion. And so after that we actually want to create two variables, two raycast hit variables to collect detection, or to perform hit detection on objects. And after that we want to set our over enemy equal to physics.raycast, and then we want to use ray.origin, so the origin of this ray, for the origin of this raycast, then cast that in the ray.direction, collect the hit data and send that over the distance, and do that on the enemy layer. And so if this is performed properly, basically we're just going to swap out that texture, or our target texture, that is. And so now we'll go ahead and do that. So we'll say if over enemy, then we'll check if physics.raycast ray origin ray direction, just like we did before. We use our second hit variable this time, over enemy distance, on the other layer instead of enemy layer. We want to use other layer. Then we'll say over enemy is equal to hit1.distance if that is less than hit2.distance. So we're comparing the two distances, and if this compare comes back true, then we set our over enemy equal to true. And then we'll go ahead and create a float called delta, and we'll make that equal to 1 subtract from 1 our player camera dot y, and this is a property that's in our player camera. This is a capital Y. So this is a property that's in our player camera that we don't actually have yet. So when we go back into Unity, this is going to throw an error until we put that into our player camera. So as a matter of fact, let me just go ahead and do that now. I'm going to come over to player camera, and what we actually want to do is we're going to make this a private method, or a private variable with a getter and setter. So we're going to have two private floats called x and y, And then for each x and y, we're going to create a getter accessor property. So right here, I'm just calling these underscore lowercase x and underscore lowercase y. For the getters, I'm just using a capital Y and a capital X here and returning that variable. And I suppose we could actually just make that public, but for some reason I've chosen to make it private, so that's how it is. And after we perform this, and this is a really long magic number, I know, but that's what it is. And so now we'll want to check to see if we are in aim mode. And if player controller.aim, then we want to set our player target.position equal to player cam.screen to world point. So what we actually want to do is translate or move that player target, this player target object to a point in space wherever our camera actually hits. So we'll say that is equal to a new vector3 screen.width multiplied by 0.7, and then screen.height multiplied by, and then 0.3 plus delta multiplied by 0.24 for the y, and then just 10 for the z. And then on the opposite side of the board, we have this else here. We'll say player target dot position is equal to player cam screen to world point new vector 3, and then again screen dot width multiplied by 0.7 for the x, screen dot height multiplied by 0.4 plus delta multiplied by 16 for the y, and then for the z 10, like that. And so now we'll want to check to see if we're over the enemy, so or compare our public and private over enemy booleans. And we'll say if our public over enemy is not equal to our private over enemy, then we'll set our private over enemy equal to our public over enemy. And then if our public over enemy is equal to true, then we want to set our GUI.texture equal to target over, swapping out the regular target texture for our red target texture. Otherwise, we just want to set our GUI.texture equal to the regular target texture. And then we actually want to perform a little bit of color change as well. So what we're going to do is check to see if we're in aim mode, and we're going to do that by checking to see if the public aim variable is not equal to the private aim variable. If that's the case, then we'll set our private aim variable equal to the public aim variable, and if our public aim variable is equal to true, then we'll change our GUI.color equal to this color here, just taking note that it's 0.5 on the RGB and 0.75 on the A. And the same way on the opposite side of the board, so if our aim variable is equal to false, then our color is going to be RGB at 0.5 and A at 0.15. And that's all that we need for our target script. So let's go ahead and come back into Unity. And player camera does not contain a definition. That's because I did not save our player camera script. Alright. And there we go. So let's go ahead and play the game and just see if that thing appears. And it looks like it's being a little bit ridiculous right now. That's not drawing in the proper way. So we need to set a width and height somewhere. Let me look into that. Okay, so definitely didn't realize this, but I reset the player target apparatus. I reset its transform and position and everything, and we actually have to manipulate the transform a little bit. So we need to set the X to 0.5, the Y to 0.5. We'll set the scale to 0 for the X and 0 for the Y. Just leave 1 for the Z, and we'll go ahead and hit play. And there is our target right in the middle of the screen right there. Alright, so now that we have our target, we can move on to our camera. Alright, so I'm going to go ahead and stop the game, and we'll come back into Visual Studio or MonoDevelop, depending on whichever one you have, and we'll go ahead and start working on the camera. So in our public, we'll need a lot of variables. We're going to need a float for the Y min limit and the Y max limit, and this just means how far up or down we can turn the camera on the Y axis. And our zooming is actually going to be performed by manipulating the field of view of the camera. And so we need to cache the original normal field of view, which we're just leaving at 60, which is the default field of view that Unity's cameras come with. And then for our zoom field of view, we're just going to set that to 30. And these, as a matter of fact, can actually be changed all throughout the inspector, just so you can tweak with the values if you have shorter, taller models, whatever. And we're also going to need a speed at which we want to lerp between those two, so we'll make a float called lerp speed, and I'm just initializing that at 8. And we'll need one for position lerp, and we'll need one for the normal height. So we'll make a float called normal height, and I'm initializing that to 1.5. And we'll also need one for the normal aim height, and we'll need one for the min height, or minimum and maximum height. So I'll just grab both of these and put them in here, and that is going to be the min height I'm going to set to 0.5, and the max height is 2, and also the normal aim height is going to be 1.8. So that's what I've set those to. And we're also going to need one for the normal distance and one for the normal aim distance. And for the normal distance, I'm just initializing that to 2.5, and for the normal aim distance, I'm setting to 1. And now, let's say that if you also had like a crouching or proning state, you would also want to include your crouch height, crouch aim height, then your crouch distance, and crouch aim distance, and that sort of stuff in there as well. Alright, so now that we have all that, we'll also need a min distance and a max distance. So put those right there. And we'll also need a boolean to tell us whether or not we can orbit the camera around the player. And so we'll just set that right there, and by default it's going to initialize to false, but it'll be set to true accordingly. And we're also going to need references to our camera target and our player transforms. Alright, so if we go back into Unity real quick and just get rid of this other one over here. And if we go back into Unity real quick, then we can see that we actually have a target object in our player hierarchy. And all this is just a regular empty object named target that is one up on the Y, so right at about the waist position of the character. And that's what our camera is actually going to be aiming at, essentially. And let's try to get that focused. Alright, so and then our player transform is obviously just our player's transform, so our parent player object. And now I'm going to show you a cool little thing that we can do with vector 2s and vector 3s. Is we may have sometimes where we need to set up multiple variables for x and y. So what I do is I use vector 3s, and we can actually use the x extension and the y extension off of those to get those values, rather than having to say we need a speed x and a speed y variable, two different variables. And we can just set up vector 2, and we can just use the x and y off of those. Alright, so we have a speed, an aim speed, and a max speed. For the speed, I just have both values set to 135, and for both the aim speed and the max speed, I have the values set to 100 on both the x and y. Alright, and so we're also going to need a public hit layer, layer mask, and this is going to be so that we can actually correct our camera's position if there is any obstacles that are in the path between our camera and our player. So we'll put that hit layer right there, and we're also going to need a vector 3 for our normal direction, and I have set the x to -1, the y to 0, and the z to 0.3. Alright, so we'll also need an aim direction, and the x for that is -1, and the y is 0, and the z is 0.7. Okay, so now we'll go into our private variables, and we already have our x and y, but we're also going to want to cache a reference to the delta time, which is literally just going to be time.delta time, but we're going to store that in a variable. And then we're also going to want the target distance and the target height. So we've created some floats for that, and we'll also need a private reference to our camera's transform, and we'll need a few vector3s for our position, our direction, and camera position. So we'll make one called position, one for camera direction, and one for camera position. And we'll also need to store the rotation, so I'm going to go ahead and put that in there, and I'm missing my underscore, so I'll fix that in a little bit. And we'll also need a private reference to our character controller. So we'll make a, or not character controller, but player controller. So we're referencing the player controller mono behavior and just calling that player controller. Alright, so in start, the first thing I want to do is disable the cursor, and that's just so that it's not getting in the way if we're looking around or anything. So we're going to set both screen.showCursor and screen.lockCursor. Screen.showCursor is going to be false, and we do want to set lockCursor to true. And then we want to check to see if our target is equal to null or our player is equal to null, then we want to destroy this instance. And what this is going to do is, if either of these conditions are true, it's just going to remove this component off of the object, and then we just return out of this. And we also want to set our target's parent. So the object that we just looked at, we want to set that to null. And then we also want to cache our camera's transform. So we'll go ahead and say cam transform is equal to transform, and this one I'm actually going to modify. We want to create a variable called angles and just cache the cam transform's Euler angles, and this is actually a vector3, so I'm going to change that from var to vector3. And we'll set our x and y to the opposite angles. So what we mean is our private x and private y variables. The x is going to be equal to angles.y, and the y is going to be equal to angles.x. And so now we want to just grab our controller component. So we'll say player controller is equal to player.getComponent player controller, and our target distance is going to be equal to our normal distance by default, and our camera position is going to be equal to player.position, so the position vector3 plus a new vector3, which we're going to say 0 for the x, and just bump up the height by normal height and set the z to 0. Now in our update method, we want to be able to enable the ability to what's the word? We want to enable the ability to show our cursor again, and this is primarily just for edit mode, but I'm sure that we could actually implement functionality to disable orbiting or disable camera functions if our cursor is showing. But all we're going to do is we're just going to check for the input cancel. So we're going to say if input.getButtonDown player input.cancel, then we're just going to set our show cursor equal to not show cursor and lock cursor equal to not lock cursor. So that gives it the toggle effect for booleans. And we can see that player input's coming up with a red squiggly under it, so we actually need to include our library or include our namespace. So we'll say include globals right here, and that should go away. And it does. And so now we want to do a little bit of a crazy check. What we're going to say is this method right here, this go to orbit mode, is going to actually toggle the ability to orbit on and off. And so what we want to do first of all is we want to make sure that we can turn it off. And the way we're going to do that is we're going to say if input.getAxis horizontal does not equal to 0. So if we do have positive or negative values in our horizontal input, then we want to say orbit mode is equal to false. Same way with the vertical, and the same way with the aim. So if we're aiming, then we don't want to orbit the camera either. And so we are also going to say if not orbit or our player controller, and if not orbit and our player controller dot idle timer is greater than 0.1, then we'll say go to orbit mode is equal to true. So if we have been idling for a little while, then we do want to go into orbit mode. So now we'll go ahead and create that orbit mode method, which is just a very, very, very short method, and it pretty much has one purpose. So we'll come into custom methods, and I'm just going to paste that in. So we have a void go to orbit mode, which we're accepting a parameter of bool, and we're calling that state. So we're going to set our variable orbit equal to state, and then set our player controller dot idle timer equal to 0 to ensure that whenever we toggle this on or off, we actually reset the idle timer. Alright, so we'll come into our late update method now. And the first thing that we want to do in here is we want to cache our delta time. So we're going to use our delta time variable, make that equal to time.delta time. And then we're going to need three methods. First of all, we're going to want to get the input of the user. Next, we're going to want to perform some logic to rotate our soldier, or rotate our player. Still have that from when I reverse engineered the boot camp. And we're actually going to want to move our camera. So, well, let me just copy that. And we'll make a method for that and just separate that all out. So firstly, we have that get input method, which is a pretty short method as well. So we'll come down into here, and I'm just going to make this a private void and call that get input. And we don't need any parameters. And matter of fact, I'm actually going to make this, instead of public, I'm going to make it private or protected, probably. So no, we'll just leave it private. So we'll leave it private. And for our input, we're going to create a new vector2, and we're going to call that A. And we're going to assign that to a ternary operator. And the condition, we're going to check to see if we're in A mode. If we are, then we're going to set A to aim speed. Otherwise, we're going to set A just to speed. Now, for our X variable, we want to add on to that mathf.clamp, and then we want to use our input, or for our value, we want to use player input dot mouse x, and then we want to multiply that by our a.x, so whatever the value of our a.x is. And then for the minimum value, we want to use negative maxspeed.x, and then for the maximum value, we want to use maxspeed.x, and then we want to multiply the entirety of this by delta time. Excuse me. Alright, and we actually want to do almost the exact same thing the other way around with our y variable, except we're going to change a couple things around. First of all, we're going to subtract from our y variable the result of this, and then we want to use mathf.clamp, and then we want to use that on our player input.mouse y this time, and multiply that by a, or the result of a dot y. And then for the minimum value, we use negative maxspeed.y, and then maximum maxspeed.y for our maximum value, and then multiply the entirety of this this calculation here by our delta time. And now we're actually going to employ another custom method, but we are going to use that on our y variable. We're going to set that equal to clamp angle, and then the parameters in here. So we need to go ahead and create our clamp angle method. Now this is actually a very short method too. What we're going to do is we're going to create a public static float. So we have a return type of float that effectively makes this a number, and we accept a angle, a minimum, and maximum value. And so all we're doing is saying if the angle that's passed in is less than negative 360, then we want to take our angle and add to it 360. On the opposite side of the board, we want to say if our angle is greater than 360, then we'll take our angle and then subtract from it 360. Then we want to return mathf.clamp, and the result of the angle for the value, and then clamp that between the minimum and maximum values that we pass in. And so what we're doing is we're performing this. Our angle is the result of uh, our y variable here, and then we're using the y min limit and max or y max limit to clamp between that we can set in the inspector. Okay, so that is our input, and now let's go ahead and check out what else we have. We have rotate soldier, and for rotate soldier I'm going to rename this to rotate player because I like that better, and I'm going to go ahead and right under, well, I guess it would make sense to put that under clamp angle because these two go hand in hand. I'll make a private void and call that rotate player, and we don't need any parameters. All we need to do is just actually rotate the player if we're not in orbit mode. So what we're going to do is we're going to say if not orbit, then we want to say player controller dot target y rotation is equal to x. So the value of our x input, which is effectively our mouse x, so as we move right or left with the mouse. And the reason that we put this in a separate method is because there may be additional logic that we want to use to rotate the player if we want to do more complex maneuvers. So we're just going to set that outside of everything else and just have this is a little bit more modular this way. Alright, so now we're going to get into the meat of the camera system, which is camera movement. So we need a new void, and I'm just going to go ahead and grab that and put that right here and close it off. And in here we're actually going to do a lot of stuff. So first of all, what we want to do is we want to check if we're in A mode, and also we want to have a condition if we're not in A mode. So if we are in A mode, the first thing that we want to do is we want to manipulate the field of view of the camera. So if you're unaware, you've never played with the field of view of a camera, I'm going to come back into Unity real quick and let this load, or let this compile. I'm going to go ahead and grab the camera and come into game view. Alright, so we have this field of view right here. So if I increase this, we can see it get farther away. The field of view gets bigger, and if I decrease this, then it gets lower. And by default, the lowest, or the setting, is 60. So that's what we have cached in our script as well. So I'm just going to set that back to 60. And so I'm going to come back into Visual Studio, and we'll go ahead and paste in the line. Basically, we're going to set the camera.field of view equal to mathf.lerp, and then we want to lerp between the current field of view, which if we're not in A mode is going to be 60, and then we want to lerp to the zoom field of view, which we're setting to 30 or something like that, and then we want to do that over a certain period of time, and we're going to do that over time.delta time multiplied by lerp speed. Alright, and so now that the hard part's done, all we need to do is just a couple of just some really simple pieces of logic. So first of all, we're going to set the camera direction, and that's going to be equal to aim direction.x multiplied by target.forward plus the result of aim direction.z multiplied by target.right. Alright, so that's how we're caching this vector here. And then we're going to set target height is equal to normal aim height, and target distance is equal to normal aim distance. So if we're in A mode, this is what we're going to do. And we're also going to need to do something on the opposite side of the board as well. So again, first of all, we need to manipulate the field of view of the camera and then send that back to the other direction. So we'll say camera.field of view is equal to mathf.lerp, our current field of view, which should be somewhere around 30 as we discussed, and then back to our normal field of view over time.delta time multiplied by lerp speed. And then we want to do the same thing with our camera direction. So we'll take our camera direction, and this time we're going to use our normal direction.x instead of our aim direction.x, and multiply that by target.forward, and then use normal direction.z instead of aim direction.z multiplied by target.right. Then we'll go ahead and set our target height and our target distance back to their normal height and distance. And so that's it for our aim logic, or our aim checking. And now we'll just come outside of there and set the camera direction equal to cam direction dot normalized. So we do want to get a normalized vector off of that. And we're going to set our camera position, or not camera position, but cam position equal to player.position plus a new vector 3. And then we're going to say that's for the new vector 3, 0 for the x and 0 for the z. Just bump that up by target height. And then we'll need a raycast hit variable to perform raycast hit detection. And then we'll say if physics.raycast. Let me just go ahead and close this off. Then I'll explain this line of code. So if physics.raycast, we use camera position for our origin, camera direction for our direction, out hit to collect the hit detection data off of the object that we hit, and then target distance plus basically a bunk value of 0.2f for the distance, and then perform that for the hit layer. Okay, and if that's the case, then we actually want to correct. So if we do run into a object that is in between our camera and our player, then we want to go ahead and correct the location. So we'll say float. We'll create a float, call it t, and that's going to be equal to our hit, whatever we hit, dot distance. Subtract from that 0.1, and then we'll subtract from our t, from this float we just created, our minimum distance, which we set in the inspector. Then we'll multiply that, or not multiply that, but divide that by the result of our target distance minus our minimum distance. Okay, and then we'll need to set our target height, and our target height is going to be equal to mathf.lerp, and then whatever our max height is that we set in the inspector, and then whatever the result of our target height is, or what our current target height is, and then clamp that between, and then get the result of mathf.clamp on the t variable that we created up here, and 0 for the min and 1 for the maximum. Okay, and then we'll go ahead and take our camera position, or again our cam position, our cam position, and make that equal to player.position, and then you know the drill, we just bump that up to our target height above the player. So we've seen that line of code a couple times already. And after that, we're just going to set our target distance equal to our hit distance, and then subtract from that 1f. So basically our target distance is going to be equal to t. And I don't see why, well, no, okay, so we're manipulating t here. We can't use t down here. Alright, so that makes sense. And from there, we'll need to go ahead and set a look point, so what we're actually going to be looking at. And we'll create a new vector 3 and call that look point, and we're going to initialize that to cam pos. Now we're going to perform a calculation on it, or we're going to calculate our look point by adding to it the result of target.right multiplied by the dot product of our current cam direction multiplied by the target distance, and then using the target right, or the dot product of these two values here. So I guess a better way to look at it would be to put some parentheses around here, so that way we can get the result off of this and just get the dot product off of these two values here. Okay, and from there what we need to do is set our camera, or our cam transform dot position. So we're going to set our current camera position equal to our cam pos plus our current cam direction multiplied by our target distance. So basically our cam direction, whatever we've calculated for our cam direction, and then add or multiply onto that how far away we want the camera to be from the player. And then we'll say that, let's see, our cam transform we want to use the look at method on our cam transform. So then we just want to look at our look point, and this is being calculated dynamically. Then we'll set our target dot position. So our current cam's target dot position equal to cam pos, and then our target dot rotation equal to quaternion dot Euler, and then for the x we're going to use the y variable. For the y we're going to use the x variable, and then 0 for the z, because we don't want to use that in a rotation. Or not really anyway. We always want our camera to be upright. Alright, so that actually should do it for our camera. Let's go ahead and come back over into Unity and see if all our warnings and errors and everything go. And so far we're looking good. And yeah, okay, so we've already set our player target up. Now all we need to do is just set up our camera. And matter of fact, these min y, min x limits, we're gonna probably wind up changing those, as well as the zoom, but we'll see what that looks like. For right now, all we need to do is just set our target object to our target variable here, and then our players transform to our player right there. Alright, so we'll go ahead and hit play and cross our fingers. Alright, so now we can actually move around. Let's test our actual rotation. So if I hit forward, yes, our player will rotate, and as I move my X on my mouse left and right, I can move left and right like that. And up and down works. And as I said, that's way too much for our min Y, min X. So I'm going to go ahead and play with these values. I'm going to change my Y min limit. Let's change that to probably something like maybe -60. Let's see. Y min limit to -60. Well, let's see. -20. Let's see what that does. Well, no, that's upwards. Okay, so I'm going to set that to -40 maybe. And 40 might be a little too less. I'm going to go back up to 60. And 60 may be too much, so I'm going to make that -50. And -50 looks good. Alright, so we need to set a min for the Y. Set that to 20. Let's see. 20 might not be enough. 30 or 40 probably. Maybe 50. Yeah, let's just make it an even 50 both sides. Alright, so I'm going to need to set this to -50 again while I'm not in play mode, and 50 here. And now let's go ahead and check out our zoom field of view. And in the editor mode, the screen, the lock cursor stuff, sometimes has a little bit of trouble. But I'm going to go ahead and right click, and yes, as I assumed, our field of view looks to be maybe not enough or too little. Let's go ahead and drop or put that at 40. 40 looks better. Let's try 45. And I like 45 a lot better. So I'm going to keep that at 45. And that should be good, at least for now. So anyway, I know this was a lot of code, there's a lot to take in, but we have our camera system set up and we're already making great progress. We only have a few more tweaks and things that we need to do before we got our system fully working. And I appreciate you watching, and I'll see you in the next video. Alright, bye.